Section 1-2 is entitled Properties of Real Numbers. So let's go through a few definitions first. Real numbers are all of the numbers that you know so far. We will get into imaginary numbers later. Rational numbers. Rational numbers are numbers that can be expressed as a ratio or as a fraction. This includes terminating and repeating decimals. Terminating decimals are ones that end, something like 0.75. And repeating decimals is one that repeats, so like 0.33333 forever. There are irrational numbers, and these are numbers that cannot be written as a ratio. For example, some of the best examples of this are square roots that cannot be simplified. So for example, square root of 2 and square root of 3. Another way to look at this is decimals that do not end or repeat. One of my favorite irrational numbers is, of course, the number pi. Integers. Integers are the positive and negative whole numbers. So from -2 going downward in the negative direction, -1, 0, 1, 2, and up in the positive direction. Those are all integers. Notice there's no fractions or decimals in there. Whole numbers are the positive counting numbers, including 0. So whole numbers start with 0 and go 1, 2, 3, 4, and so on. And natural numbers are the positive counting numbers that do not include 0. These start with 1 and go 1, 2, 3, 4, and so on. So there's a really cool chart in your textbook, and I tried to copy it here, not quite as neatly, that shows you kind of the different categories of numbers that we know. So the largest box here is represented by the letter R, and that's the real numbers. So all the numbers you know are real numbers. Within real numbers, there's Q and I. And somebody decided that Q is going to stand for the rational numbers. So rational numbers and irrational numbers. And there's no other categories within irrational numbers, but within rational numbers, you have the subset of Z, which is integers. Within integers, you have whole numbers, and within whole numbers, you have natural numbers. And I've given you some examples here. I think the book chart in the book is color-coded, so you might want to take a look at that. So let's try a couple examples here. Name the sets of numbers to which each belongs. Well, every number you know is a real number, so these are all going to have an R for real numbers. And 3/4 is a fraction, so that is a rational number. The letter we use for rational numbers is Q. It is not an integer since it's a fraction, and since it's not an integer, it can't be a whole number or a natural number, so just real and rational. -7. -7 is a real number. It is also a rational number because that can be written as a fraction, -7/1, and it is an integer since it's a negative whole number. But remember, whole numbers and natural numbers do not include negatives, so it can't be one of those. Square root of 8 is a real number, but square root of 8 is approximately 2.2 something, I believe, that goes on forever, and does not end and does not repeat, so that makes it an irrational number. And remember, there were no subcategories under irrational. 0. 0 is a real number. It is also a rational number because you can write 0 as 0/7. It is an integer. It's in the set of integers. It is also a whole number, but it is not a natural number because remember, the natural numbers start with 1. And 7. 7 is a real number, a rational number, an integer, a whole number, and it is also a natural number. Properties. You've probably been learning these since sometime in middle school. Here are some properties of real numbers. So we have the commutative and associative, and we have those for both addition and multiplication. Basically, commutative says that you can commute or you can rearrange the things that you're adding or multiplying. Associative is the one that involves parentheses, and notice we haven't changed the order. They're all A, B, C, but how they are associating together with the parentheses is different. Identity and inverse. Let's talk about those identities. And again, this is for addition and multiplication. What can I add to something and get the identical thing out? So adding to A, I'd have to add a 0, because A plus 0 equals A, and 0 plus A equals A. What do I have to multiply by a number to get the identical thing? And that would be a 1. So the multiplicative identity is 1, or what you have to do to get a 1. Inverse. Inverse kind of means the opposite, especially for addition. So the additive inverse is adding the opposite of the number to get 0. And then the multiplicative inverse is what do you have to multiply it by to get a 1. Notice that for both of these, 0 is important for addition, 1 is important for multiplication. Closure property, we're not really going to use this, but they throw it in the book. Basically, it says if you add two real numbers, you get the sum is a real number. If you multiply two real numbers, the product is a real number. And one of my favorite properties here is the distributive property. A times the quantity B plus C, the A gets distributed to the B and to the C, and then you add them. We can also put the quantity that we're multiplying by after the parentheses. So A is still multiplied by B, and A still gets multiplied to C as well. So name the property that's illustrated by each equation. So 85 times 19 equals 19 times 85. Since there's no parentheses or anything here, this is going to be the commutative property. And I want you to be specific. This is the commutative property of multiplication. 2a times the quantity 1 over 2a equals 1. This is going to be the multiplicative inverse. So you can either say multiplicative inverse. Oops. Don't use mi. That could be multiplicative identity. But this is the multiplicative inverse. Okay? Negative 3 plus 3 plus, in parentheses, plus 7 equals 0 plus 7. This is a little confusing, but notice what we're doing here is we're basically saying negative 3 plus 3 equals 0. This is actually the additive inverse. Okay. And 10 minus 3, the quantity 10 minus 3 times 8. It looks like that 8 is getting distributed, so this would be the distributive property. Okay, so find the additive inverse and the multiplicative inverse of each number. In other words, what do I have to add to negative 7 in order to get a 0? So in this case, the additive inverse is going to be 7. And what do I have to multiply by negative 7 by to get a 1? So the multiplicative inverse is going to be a negative 1/7. What do I have to add to this to get a 0? What do I have to multiply this by to get a 1? For 1/4, my additive inverse is going to be a negative 1/4, and my multiplicative inverse is going to be a 4. Because 1/4 plus a negative 1/4 is a 0, and when I'm adding I want a 0. 1/4 times 4 gives me a 1, and when I'm multiplying I want to get a 1. Third example here, negative square root of 3, don't let that throw you. The fact that we have a square root, the additive inverse is going to be a positive square root of 3. And the multiplicative inverse is going to be 1 over the negative square root of 3. And last couple examples here. Let's simplify each one of these. So it looks like I'm going to have to use the distributive property here. That's going to be my first step. So distributing the 5, this is going to give me 15x. And distributing the 5 again, that's going to give me 30y. Distributing the 4, I'll have 8x. Distributing the 4 again, negative 36y. And remember that we need to combine like terms. Like terms have exactly the same variables, raised to exactly the same powers. So I have a 15x and a positive 8x. That's going to give me a 23x. And then I have a 30y and a negative 36y. That's going to give me a negative 6y. And that's my final answer. Remember when you did this in Algebra 1, you may have used colored highlighters or different colored pens. Please feel free to do that in order to make sure that you're combining your terms correctly. Okay, yay, some fractions. Let's not be scared off by those. 1/3 times 5 is 5/3 x. 1/3 times 8y is 8/3 y. And 1/4 times 6 is 6/4, or I can simplify that to 3 over 2x, minus 1/4 times 2 is 2 over 4, or 1/2 y. Maybe I'll go ahead and do some color here. So here I have my x's, and here I have my y's. And look at this, I get to do some common denominators here. So 5/3 x and 2/3 x, my common denominator is going to be 6. So this is going to give me 10 over 6x plus 9 over 6x. Finding a common denominator. For my y's, I have 8/3 and 1/2. Again, for that, my denominator is going to be 6. So this is going to give me a 16 over 6y. And with a common denominator of 6, that's going to give me a 3 over 6y. And now just combining the like terms, 10 over 6 plus 9 over 6 is 19 over 6x, and that cannot be reduced. 16 minus 3 is a positive 13 over 6y. And there's my final answer for that one.